class, this is help with page 9 and 10 of your practice book, so just some homework help. Okay, let's get started. So on number 1, we're deciding if each of these is true or false. If you expand these out, you'll have 3 5 times multiplying itself, and 3 multiplied itself by 7 times. So that would be a total of 3 to the 5 plus 7 is 12, not 3 to the 35th. You don't multiply the exponents here, so that would be a false. On this next one, as you're working through, notice there's different bases, so that would give you 18, okay, to the third, and then if you raise that to the second power, 3 times 2, yeah, that gives you 18 to the 6th. That one's true. On this one, as you're looking through, careful, remember a negative exponent drops to the denominator. So that means that that 7 to the 6th would drop to the denominator, and you'd also have 7 to the 4th in the denominator. So when you combine those, 4 plus 6, that's going to be 10, so that one's true. As you're looking through this, if you expand them, picture your 4s, your 2s, add those up, add those exponents, and you'd be left with 4 to the 6th. That's true. Careful here. The common mistake is 0, okay? So on this, remember, a negative exponent drops to the denominator. You already have 13 to the 4th, and then you're also bringing down another 13 to the 4th. So that should be 13 to the 8th, not 13 to the 0. That one's false. And on this last one, I notice right away that it's to the 0 power, so that means it should be 1, and this is definitely not 1 over here. That one should also be false. Okay? Alright, I'm going to scroll up here, so we're going to lose a little of the writing. Alright, so on problem number 2, here we go. So Tyler simplified the expression 5 to the 4th times 5 to the negative 9. All of his work is shown below except that answer. So looks like Tyler was adding those exponents. That looks good. We got negative 5. So that means that this is in the denominator. B makes sense. Completing this table, so we're simplifying these expressions. We have 10 to the 4th, and then 10 to the negative 2. You can add those, and that will give you 10 to the 2, or 10 squared. You could also expand that out, so you'd have 10 times itself 4 times on top, or in the numerator, twice in the denominator. Looking at this, you have different bases, so that gives you 35 to the 4th power. And again, one more time on this one, you have different bases, so that gives you an 8. 2 times 4 is 8 to the 7th, and then you're going to raise that to the 3rd power. So total, running out of room here, you'd get 8 to the 21st. Okay? Alright, again, we're going to lose a little writing. I'm going to switch papers here. So, last part of your homework. Okay, if you simplify this, right away I notice there's a negative exponent, so it drops it to the denominator. Okay? So, you would have already 32 to the 6th power, and then you're also bringing down 32 to the 1st power. So total, you're going to end up with 32 to the 7th power in your denominator. Another way to write this that means the same thing, you could write it 32 to the negative 7th power. That means the same thing. So both of these can go in your answer or solution part down here. Next part, number 5 and 6. So on number 5, we're going to rewrite 9 to the 6th power as a base of 3. So if you expand out 9 to the 6th, you have 9 written out 6 times. That means 9 to the 6th power. But we don't want a base of 9, we want a base of 3. So if you think 3 times 3 is going to get you 9, that means each one of these 9s can be broken down to 3 times 3. And you can keep going with that. So total, you'd have 3 to the, let's see, there's going to be 2 of them for each one of these 9s. So that would be to the 12th power there. Okay, oops. On this last one, so which expression is equivalent? Okay, so 3 to the 4th times 5 to the 4th to the negative 3rd. Okay, so we're going to pick the correct answer here. All right, so let's see, that would give us 15. All right, keep our exponent there, 4. And then we're going to raise that to the negative 3rd power. We'd multiply those, so you'd have 15 to the negative 12. Now, none of the answers match that right now. But right away, I think, oh yeah, negative exponent drops to the denominator. So that means 15 to the 12th is going to drop to that denominator. And then that would match C. Now, in this case, Tanya picked B as a correct answer. How did she get that? Well, looking at kind of common mistakes, one way that she could get that is she didn't use order of operations, so maybe she didn't start with a parentheses in here. Okay. Maybe she multiplied all of her exponents as well, like 16, and then to the 3rd. So that's a couple ways that she could have gotten that. Okay. All right, hopefully this helps on your homework. I will see you guys tomorrow. Study for your Try 1. Thanks. Bye.